these big foundation models like OpenAI's and everything, you just throw a ton of data and it'll figure it out. For these small, tiny, efficient models, you have to label the data really, really well.
We would talk on the phone and be like, oh, this is such a, we should make a podcast. And we just started recording the phone calls.
Oh, amazing. That's fantastic. I love that. I should do that with my co-founder, just 6 hours back and forth about like culture and all that kind of stuff. I'm sure everyone would just listen to that verbatim.
Oh, well, I mean, at least the 30 listeners that we have would come listen to it.
Okay, brilliant. All right, perfect. Wonderful.
All right.
Everybody, welcome to this week's episode of How Many CTOs Does It Take? My name is Scott Porad, and this is my trusty co-host,
Brad Hefta-Gaub.
And Brad, who do we have with us here today?
We have a very special guest with us today, Carter Huffman, the CTO and co-founder of Modulate AI. And Carter, would you like to introduce yourself and tell us what brought you here? How'd you get here? Not flights, but you know.
Yeah, right. Right. So I was in this British Airways flight for 11 hours typing like a T-Rex. Yeah. And that's why I'm on your podcast. Everyone wants to hear about that, I'm sure. No. Hi, everybody. I'm Carter Huffman. I'm the CTO and co-founder over at Modulate. We're a voice AI company. We deal with cost-effective, accurate voice AI models at scale. There's a ton of fun stuff to talk about there. And before that, I was doing machine learning and artificial intelligence over at the Jet Propulsion Lab. So working on some cool like spacecraft autonomy machine learning. So if we want, we could talk a little bit about that too.
Very cool.
That does sound very cool. Like you were working on autonomous flying airplanes?
Autonomous science on spacecraft, which is
science on spacecraft.
Autonomous science, yeah. So what that is basically like here's the one kind of one I love the most. Is okay, so you've got like a mission to a meteor, like an asteroid, comet, what have you, right? And these missions are expensive, right? You know, $100 million. You spend 10 years building this spacecraft, and you send it up, and it travels for 2 years, and it flies by a comet, you know, a light hour away from Earth, right? That flyby takes 15 minutes, maybe max, right? 15 minutes, you're there with this comet, all of that stuff for 15 minutes. And as you're doing this flyby, maybe you see something interesting, like a little jet of gas coming out of the comet, or a little bright spot or something. And if a human's looking at that on Earth, they're like, oh, that's really cool. Let's go take a closer look. But it costs so much money and so much time to get there. No one's ever going back to that comet ever again. This is the only time humanity is going to see it. And so the stuff I was working on was like, can you, with your decade-old, you know, less powerful than a first generation iPhone CPU on this spacecraft, find interesting stuff while you're doing the mission, and then go kind of do a follow-up observation on it, even without a human in the loop. It was really cool stuff.
That is pretty cool.
You know, $100 million spacecraft mission in the age of AI data center spend sounds like a bargain.
You know what? That's right. We should just send ChatGPT to every single asteroid in the solar system. That's amazing. Because you know what AI needs? AI needs more CapEx. That's what AI really needs. They need to spend more money. That's what was missing.
Well, isn't that the strategy behind Elon merging XAI with SpaceX? Like, you know, all the CapEx just looks the same at that point.
Those games are so beyond me. When I run multiple trillion-dollar companies, I will come back to you and I will say, okay, now I finally get it. Now I finally know why Twitter has to go to space, right? But you know, I'm gonna have to get back to you on that one.
Yeah, exactly.
So what was your journey from JPL to Modulate? How did that come about?
It was really cool, yeah, because you don't necessarily think like, okay, NASA, and then go straight to like software tech or something. But there's actually this really cool parallel. So at JPL, I was telling you about kind of doing this low power machine learning stuff on the spacecraft, and that's a lot of kind of analyzing signals and variation in signals over time. And around that time, this was 2014, 2015 or so, people were doing some really cool stuff with AI and machine learning, like early days pre-LLM. So for example, one of the things I really loved was called GANs, Generative Adversarial Networks. And that had this cool capability where you could take a picture of me with my glasses and you could use the GAN network to take my glasses off and it would make a kind of realistic image. And you could do all sorts of futzing, change my hair color, this sort of thing. And like nowadays, these are in all the apps, like nobody thinks that's really impressive, but that was the first time you could really do that with high quality images. And the really cool thing about neural networks, like the entire reason why these have, because an LLM is just a neural network, a transformer is just a neural network, right? The entire reason why these algorithms are so cool is they're very, very agnostic to the input kinds of data. So you can do something cool with the neural net on an image or on text or on a video. I was seeing this stuff and I was like, well, you could do that for audio too. And audio is like, okay, that's just a signal with a bunch of variations and stuff like that. I was a physicist by training. Like they deal with waves, like quantum waves all the time. These sensor measurements, those are kind of like waves. Audio is a wave. And I'm just like, it's all waves. I know the math behind this already. Why don't I work on audio? And so that's when I kind of just like nights and weekends, over a few years, started getting into how can I apply these AI neural networks to audio? It's gotta be possible. I ran into a ton of challenges, but that's sort of where it came about.
Cool. Did you already have a passion for audio? Like, like you just are you a music nerd or something like that as well, or is it more just kind of like what types of waveforms can I apply neural networks to?
It's so much worse than that. I'm a like math and data nerd. So I was like,
Well,
oh,
you're into
this
math
data
rock.
type that I understand. You know what? I was in at Stanford. I was at math camp in Stanford when I was in high school, and we did a little impromptu a cappella group. And so for the talent show, I was part of a 5-person part of your world a cappella. So
There you
um,
go.
yeah, probably the nerdiest audio there is out there. But no, it was really the signals and the data type. It's like, hey, I understand how to manipulate this because audio is really cool. It's like, and voice is really cool. Like you think when you're doing machine learning on images, you generate a face. You can see a face in anything, right? You see faces in the clouds all the time. You can see a face in anything. So if it messes up a little bit, you're still going to see a face. It's actually fine. We're very tolerant. If you mess up audio a little bit, we immediately say that sounds off. Uncanny valley straight away. And there's like evolutionary arguments for this of like, okay, if your voice sounds wrong, maybe you're sick or, maybe you're lying or something like that. But audio is such a severe
Interesting.
environment. And so you have to massage and manipulate the data to make machine learning work on audio pretty well.
Very cool.
So, I mean, I got a lot of questions I could ask, but I'm going to kind of just go to the top of the pyramid of questions. How are people using it?
Fantastic question. Love that pyramid. So primarily right now, what our technology does is it understands conversations very, very thoroughly and cost effectively. So
Mhm.
what happens is we're deployed in video games, call centers, and other areas like that. So you have two people talking in a game and they're harassing each other, right? Or somebody's harassing somebody else. We're picking up on that and saying, okay, based on what you said, but also the tone of voice, the emotion, the back and forth of the conversation, maybe your history. Have you been, spatting at each other for the past 10 minutes, or is this just coming out of nowhere? What is this person's intent? Are they really being toxic to this other person, or are they just trash talking or something like that? That's kind of where we got started. And that's a really cool challenge because you have to be right. If you ban a gamer, and they didn't deserve it, they're going to go on Twitter. They're going to yell at you. They're going to be super mad. They're never going to play the game again. They'll probably be mad on Twitter anyway. But it's kind of a thing you really don't want to get wrong,
Right.
and you also have to do it at scale. So like a big game, Call of Duty, Fortnite, they could have 100 million hours a month or a billion hours a month of audio, and at transcription costs, you call it 10 cents to a dollar per hour. Nobody's going to pay $100 million per month to just make their game
Yeah.
secret.
I got to be honest, I have a hard time imagining how this works. So, an audio stream comes into your model, and then what comes back out? Like if I think about ChatGPT, I put in a stream of words and I get a stream of words back out, right? But here, like I'm putting in a stream of audio and I actually want to get like some metadata back out about it.
Yeah.
Like what was the tone? Yeah. How does that work?
So we actually have this kind of multi-level representation of a conversation that we build and then we like update it over time. as the conversation's going on. So you get a transcript, for example, right?
Hmm.
That's kind of easy. You just get a transcript that's sort of this streaming set of
Hmm.
text. What were you saying? You're also getting kind of an emotion signal over time. So we have like labels like, okay, you're angry right now, you're angry right now, you're angry right now.
Interesting.
Now you calm down, now you calm down, now you calm down. Those kinds of things, accent, labels, same exact kind of thing. So that's what we call the signals, right? You take in the audio and you're extracting these low level sort of individual signals from the audio of like what's the tone of voice, what's the emotion, what's the accent, what's the text content of what you're saying, etc. That's kind of
Hmm.
layer one. And then on top of that, we're running a separate set of models that are taking in that stream and constantly saying, okay, what's my take on what's happening right now? Is somebody harassing somebody else? Yes or no? Is somebody trying to manipulate somebody else? Yes or no? Is somebody talking to a child in a way they're not supposed to? Yes or no? And we've got these kind of models running along, and they're constantly evaluating all of these rich signals, combining them together and saying, at any given time, are we confident in any of these bad things happening or
Yeah.
any of these interesting things happening?
Yeah. Cool. And so if I'm picturing this correctly, whether or not you're using some neural net tech, which is essentially, I mean, the really simplified way of thinking about all these neural networks are signal in, neural network, signal out. And you train the neural network to give you signal out that matches what you want the signal out to be based on the signal in. So your signal out might be aggressive or friendly. That's the signal out that you're training on. And the signals that are coming in are these multiple layers of these other signals that have gone through neural networks to produce each of their kind of signal layers. Is that a fair way of describing it or overly simplistic?
No, no, no. I think that's a fantastic view of it. And basically, the magic comes from layering on a bunch of these. So if you want to go straight from just a raw audio signal, a raw audio waveform, to is this person spreading violent radical propaganda? That's a really hard problem. But if you go first to say, well, what tone of voice are they using? What are they saying? Where do they, what are all these different pieces? And then you say, okay, based on those different pieces, if we're confident in those, how can I put that together into something more complicated? You do like three levels of that hierarchy. Now, one, you can be a lot more confident in the result because you're built off of building blocks that apply to more situations. You've got kind of more relevant data that you can train on, and it's explicable as well. Why do we think you're being this kind of violent extremist? Well, because you were really angry, you said these words, and when this person said a dog whistle, you did this thing to it, right? All of those different pieces can come together in an explicable way.
Yeah.
Language. Is it language agnostic or is it English only? How's that work?
Good question. So the whole system has support for over 60 languages, but
Hmm.
this ensemble tech that I'm talking about, when you really dig into it, it turns out that having just one neural network support 60 different languages is so expensive. So
Yeah.
kind of the whole trend for AI is build a bigger model, build a bigger model, build a bigger model. And the great thing about big models is they're so flexible. You can ask ChatGPT anything, and it'll have
Yeah.
an answer.
Might not be true.
It might not be true, and you're spending so much power and energy
Yeah.
and water and everything, right, to
Yeah.
get to that answer. And almost, that the ChatGPT also has the Bible memorized, but it's not using the Bible to answer your question. Probably, like
Right.
you're wasting so much of that neural network just to get you your one answer about, what breed of dog is whatever, whatever something. So
Yeah.
you're wasting so much capacity when you're building this big general network. We go literally the exact opposite. We say let's have 100 different tiny networks, and each of them aren't going to generalize well. They're only going to do one thing on one type of data. Maybe like we only do a good job transcribing romance languages in Discord quality audio, but you call in on an 8 kilohertz phone line, it's going to be trash. But then you have another model that handles the phone line and another model that handles another thing. And then you have to pick, you orchestrate between those different models and say at any given time, which model's the right one to run. And that one will handle it. So each individual model handles maybe one or a few languages, but the whole
Yeah.
system can handle a bunch.
Yeah. And I can picture that like the neural network that's transcribing from, like you said, English to over, a low quality audio stream is going to be very different than the neural network that is trying to pick up tone, anger, or happiness or whatever, the tone neural network. And I would imagine that some of these neural networks probably are a little bit language agnostic. Like maybe the tone one is maybe it's not culturally agnostic, but it would be language agnostic, right? So I'm assuming that this is really kind of the magic. You've built all these different pieces that are good at really, really good at one part of the problem, and then orchestrating them all together to put it together is the magic.
You've got it 100% right. Yeah, each different kind of model has different properties. So like the emotion model, for example, yes, it's our basic emotion models tend to be more language agnostic. But on the flip side, you try to apply it to Mandarin or another tonal language where the tones are actually meaningful, and it can't figure it out at all. You have to have a separate tonal language emotion model. Otherwise, you're going to be super, super confused. Kind of like normal people can be confused when somebody else is speaking a different language and you're like, wow, that German person is always angry all the time, right? No, it's just, okay, do you have your German emotion model tuned?
Right.
Yes or no, right?
Du bist mein Liebchen.
Yeah, exactly. How dare you, right? But that actually brings out a fantastic point, really, because with these big foundation models like OpenAI's and everything, you just throw a ton of data and it'll figure it out. Spend a ton of money doing it, but you just throw in a ton of data. For these small, tiny, efficient models, you have to label the data really, really well. And so if you have a bunch of people, from Boston labeling a ton of German or Russian data, they're going to get it wrong and our model's going to suck. And so
Yeah.
one of the key pieces for us was actually finding, vetting, and coordinating like globally distributed set of folks who can give us the right labels and take on the data so that we can train these systems correctly.
That's interesting.
How big is your team?
We're about 45 people right now,
Yeah.
about, maybe 17, 18 engineers, and then 15 or so commercial folks, couple ops people, few
Mhm.
executives that do podcasts and stuff. Most of the people do the real work.
I was going to ask sort of similar, I think, as you're talking about like the people doing labeling and things like that. I mean, I'm assuming those aren't part of that's part of your magic is like finding the labelers, outsourcing the right labelers, f finding a way to vet them. What is the hardest problem you've had to solve in doing this? Like, I mean, it sounds like so many hard problems. What's the hardest problem you've had to solve?
There are a couple. I guess you could say one really difficult one has been all the different definitions that different customers or team members or anybody has for certain kinds of behaviors. Because if you're just transcribing something, if we were just a transcription company, that's relatively unambiguous, not perfect, but mostly you can agree on what this person said at any given moment. But if you're saying, well, is this hate speech because you said this awful slur? Well, it might be, but it might be reclaimed language because people use slurs in positive ways. But you
Yeah.
can only do that in certain situations at certain times.
Yeah.
And it becomes very, very nuanced. And then, we kind of go and form this really nuanced opinion about like when is the slur okay or not. And the customer comes in and says, that's super nice. You just can't say that in my game. And so we're like, okay, well, that's a completely separate kind of take on that problem.
Yeah.
And so we're trying to build an anti-harassment model, and everybody has different definitions of harassment.
Yeah. Yeah.
Mhm.
Yeah, I was one of the teams that I work with is in the cultural institution space and like working with museums and things like that. And they were confronted with this recently and they're like, well, what do we do about the fact that like if someone's going to be talking about a Black History museum where slavery and lynching is discussed, like we can't just like say you can't use the word lynch, like not if you're having a intellectual conversation about a historical fact, right? So it's an interesting problem.
Absolutely. Or take, video games where you're talking about, oh, go over, kill people, or okay, well, I'm just gonna commit suicide and then I'll respawn or whatever, right? Like it is very difficult for a neural network to figure out if that's acceptable language or not. It's a really, really hard problem. And so we had so much time and energy and effort and money put into how do we build out these really nuanced understandings of all these things? And then where do you draw the line between your model, because you have to classify some of this stuff. Otherwise, you're just handing people a stream of text and say, you figure it out.
Yeah.
Um, but on the other side, if you're too opinionated, then everybody's going to have a different opinion and they're going to have to circumvent your model anyway. So, what was the point? Finding that
Yeah.
balance of how much control versus how much do you build, really, really tough problem. Everybody has different opinions on it.
Totally.
The other really tough problem, maybe if you want to talk more just like hard tech, was coordinating all these models. So most folks is like, okay, you've got one big model, you run the data in, and then once you get the answer out, you're good. But we have this ensemble of like 100 different models, and they're all running on different resources. One of the nice things about our ensemble approach is you can run on a 10-year-old GPU because it's a tiny model. You'll still get acceptable performance. You don't need the latest and greatest. So we've got all these little clusters of different models. And normally you just kind of push the data through and then you get all the data back out, you combine it all together, and you get an answer. And that's great. But when you're operating at 100 million hours a month or a billion hours a month, having to wait for every machine to respond to every answer, now you've got this massive bottleneck and you slow everything down and lock everything up. So we have to do really kind of relaxed best effort parallelization, which means not all the data gets together at the time that it's needed to make a decision. And then you make a decision, and if you want to go audit that decision later, you're like, well, did it even have all the data in the first place? Like, why did it make that decision? It's supposed to be explicable, but what happens when some of the models drop out? And so making this stuff robust to how can I still give good guarantees and good answers when I might have 10% of my models fail to return a result in time and I have to
Oh,
just do the best I can.
that's wild. At that scale, like that's when stuff gets really interesting for
It
sure.
was it was really fun when Call of Duty launched. I think this was the November 2023 launch, and we ran them out of A10 GPUs in US East 1. And so we're at like, okay, we've taken 2,000 of your GPUs, and now we don't have any more. And we're like, okay, we had some people on a team going and being like, okay, which other region has these GPUs? Okay, US West 2? All right, awesome. I'm going to submit a request for quota increase. And then the rest of us are like, okay, which models do we really need? How do we balance out, like, okay, how important is accent right now? Or like, can we get 80% of the accent coming through to get 95% of the transcriptions coming through? And we were like balancing that in real time while this game was launching.
Wild.
You mentioned video games a handful of times. I've been sitting here trying to imagine what are ways that this could be used. And so I'm just curious if you're willing to share what are the different ways that the model is being used? Because I bet there's some ways out there that people, myself, couldn't possibly imagine.
Well, I think it's really cool because that's kind of a bit of the evolution of our company.
Hmm.
Was we started out in gaming. That was our beachhead market, which is why I talk about it a lot. We just have so much history there, and I'm a gamer.
Hmm.
Um, and we were, publishing these case studies and stuff like that. And we got some folks reaching out to us saying, "Hey, you can find harassment in these games. We're a delivery company. We have drivers going and delivering stuff physically to people's doors. And if they have questions, or the person receiving the package has a question or something, they can call the delivery driver. And most of the time, that's great. It's just like, hey, FYI, my door code is whatever. But sometimes they'll call and say, where's my package? And if you're like, well, I'm on the way, maybe they're in a rush and they get really upset. And a smaller fraction of the time, people get really upset and start making threats. And a very small percentage, but tragically not 0% of the time, they follow through on those threats. And it's really rough because you've got to go bring this thing to their door. So you're going to meet this person that is calling you on the phone, threatening your life. And
Hmm.
and so obviously you just don't want to go do that. But the problem, and a lot of these delivery companies and two-sided marketplaces, right, all these sorts of things, the problem you get is that the folks doing these deliveries or services, if they cancel, they're worried that that counts against them and they might lose their
Hmm.
job and they might lose their source of
Yeah.
income. And it doesn't matter how much the company says, that's an okay reason to do that. Like, metric traffic is imperfect. People are worried about losing their jobs. So they'll go through with these unsafe situations.
Yeah.
Hmm.
So this company reached out to us and said, we want you to monitor the phone calls and find these threats of violence, and we'll stop the delivery so that we don't have to force the driver to choose between potentially their job and their own safety.
Yeah.
Hmm.
So we were doing that. And we were running our models, and we were finding all these high stress, emotionally intense situations that didn't involve threats of violence. And we're like, what could be so stressful about receiving a package or receiving an order? And we were we were looking in, and what we found is that we were actually seeing attempts at manipulation and fraud of the person calling the driver and trying to get them to change the order or what have you, and emotionally pressuring them. And so parts of our models were picking up these really stressful situations. The rest of our models didn't know how to handle. And so we were looking at that and we were like, wow, we were finding this stuff. Isn't this weird? And the company was like, oh, crap. Okay. Yeah, that's really bad. We need to catch that too. Can you catch that for us as well?
Yeah.
So customers actually led us into finding these things. So now we're doing anti-fraud, we're doing like call centers, you're calling in and you're like somebody's trying to socially manipulate their way into you're getting a password reset, and the agent says, sure, fine, yeah, that sounds like a tough situation. You lost your phone, you're traveling. Yeah, here's a new password. Um, we find all that kind of stuff um, and escalate it so that folks can solve those problems. Now, the newer use cases come around like when AI's voice agents start misbehaving.
Mm.
Yeah.
So I don't know if you all have run into any fun little AI voice stories or anything like that. We have some good ones over
Hmm.
here, but
That's pretty interesting. So, right, so we use an outbound call AI voice agent at TaskRabbit to call, piloting it right now, to call either clients or taskers in certain scenarios. And it never occurred to me that the AI could get snippy, could get potentially get frustrated and behave badly, but it probably could.
oh, we have one customer who's an interviewing company, and they have an AI bot that they were trialing to do their first round interviews. And they told the bot to check if the candidates were flexibly minded, and it started asking them to do yoga poses on a phone call. And they're just like, what what on earth?
It's so
So
funny.
that's actually kind of a new part of our business, which is interesting. Is like, we're listening to these AI bots on the phone calls, and they just do stupid stuff that no human would normally do, and you don't even know to look for it. And we're
Yeah.
like, okay, can we find all this inappropriate stuff and escalate it so you can be like, okay, great, my interview bot is asking people to do yoga poses. That's bad. Let's go fix it.
I feel like you've also like landed on essentially a better version of a polygraph, right? It's essentially lie detecting, or could be used for that. If you're not already doing that, I have to assume someone's using it
I
for
can't
that.
I can't confirm or deny that.
Can't confirm or deny that. Wait a second. My model says that may have been a dodge.
Yes, it is. It's like I think ultimately speaking, what I find so compelling about what we're working on here is that conversation is so much more than just the textual content of what you're
Yeah.
saying.
Yeah.
You pick up so much from my tone of voice, from my emotion, from my inflection, how it changes over time, everything. And when you're trying to do something, add value, do something worthwhile on top of that voice signal, taking in the whole range and dynamic of what's being conveyed in that voice signal is incredibly important. And when you throw most of that away and just go with the text transcript, you can have the smartest system in the entire world consuming that text. It will just not have the data
Yeah.
to appropriately interact with you and respond with you. And so when you're talking to an AI on the phone and you're like, oh my God, just get me to a human, like that's why. It's not because it's not a smart enough algorithm, it's because it doesn't have the data to do it correctly.
We've talked a lot about this in a commercial sense. I've been thinking about, is there any sort of like therapeutic uses for this?
We have actually had some folks asking us about putting it on like remote telehealth calls and monitoring the emotion both from just a like almost like QA purpose of just like, hey, is this person kind of responding appropriately to what this patient's kind of signals are, but also from a diagnostic perspective, which is a really
Mhm.
interesting and challenging. Like anytime you get into AI diagnostics, you get into a very, very challenging and interesting space. But what can we pick up based on the fact that we can listen to hundreds of thousands of people talking about, things in a therapy context? What kinds of signals and cues can we pick out that you would only observe at scale? And this is especially interesting when you start talking about like more generational trends, right? Because doctors have tons of training on what kinds of ways can I sort of look into somebody's behavior to help diagnose something that might be going on with them. But everybody's shaped by the society they're in and the people around them. And so you get kind of the next generation of folks coming up, and they respond to things very, very differently from what your textbooks say. And but by looking at that behavior across a very, very large range, can you start to pick out some of these signals and do a better job helping out a doctor who might not have a ton of context on that?
Yeah.
Yeah, you talked about tele, digital health. It's a thing Brad and I spent a minute working on. And I was even thinking about like just what even about like ambient
Yeah, in the doctor's office.
in the doctor's office, or even just, I had that thing happen the other day, right? Where I was talking about getting the tires on my car replaced to my friend. And then my friend reported to me that the next day she started getting ads for tires on her phone, right? Because
Ooh, I don't
her
like that.
phone's, no, nobody likes it, but it's true, right? So her phone heard me talking, right? So like, but think about the ambient use, whether it's a doctor's office or just the ambient uses for this thing. I don't know what they could be, but it's interesting.
Well, I think one of the really cool things, and this starts to get into like a little bit of the future stuff, which is like, why we do tech, right? One of the really cool applications in the future, because we've talked a lot about the emotion and context and that understanding is also the sense of scale, right? Like our stuff, we really focus on that lower cost efficiency because again, you're not going to pay $100 million a month to moderate Call of Duty, right? So that was kind of our heritage was we've got to be really, really low cost at this stuff. And so you can think of like, okay, well, today I'm going to transcribe every Zoom call, and you can do that. But tomorrow, what if I'm going to transcribe just every random conversation that people are happening all around the office or all around, the wherever? And that is, on the one hand, super frightening from a privacy perspective.
Hmm.
But on the other hand, there's a lot of potential around being able to keep track of and organize information at a scale that's been completely unheard of
Hmm.
in the past. That's enabled by being able to do like really, really cutting edge, highly accurate, sophisticated AI on data coming from just everywhere all at once.
Yeah, and even the strategies that you're talking about, you've applied it to audio, but the notion of, an ensemble of small models, that's a way of thinking about data processing in general, right? There's other forms of data, whether that be audio data, like you're doing with Modulate, or video data, or, you know, text data or temperature data
Sensor
or whatever
data,
it is,
yeah, from
sensor
your
data.
car, your phone, all that kind of stuff. Absolutely. Yeah. And these ensembles of small models are so powerful when you're talking about the embedded world as well, because you can't ship Chat GPT to your phone or your
Yeah.
car or a pin or something like that. But you can ship a ton of tiny models, and then as long as you can be pretty smart about picking the best one to actually stick into RAM and run, you can get really general high performance without having to run this massive neural net all locally, in your
Hmm.
2014 Prius C.
I'm curious. So far we've only talked about sort of the input of signal to the signal and out being like inference of like is this person angry, whatever, harassing, etc. Is Modulate also taking this clever approach that you've done to do the opposite of generating audio that is emotionally relevant? Or where are you guys on that?
I have so much ambition around that. Our team is so, so excited about it. Ultimately, we love everything about voice. We love everything about voice. We started with these voice skins, these voice changers, right? Like really low latency, really low power, run on device while I'm having this call, make me sound like Scarlett Johansson or Taylor Swift or James Earl
Right.
Jones. That's where we got started. God, we were working on the research behind that a decade ago. So we are so interested in high quality audio synthesis, all of these kinds of things. At a 45-person startup, you have to find some place to start. And
Yeah.
so we are so focused on building the best, most cost effective, fastest conversation understanding models in the entire world. And we have so much ambition to take exactly that same strategy and move it to manipulation and synthesis as well.
Yeah.
It's actually interesting kind of that you're bringing this up because in the understanding space, you can just like fan the data out, run it through a bunch of models, and then collect everything back. It's not immediately obvious how you would do that just to make like a high quality waveform synthesis, right?
Yeah.
Like it's just like, do you make a ton of different waveforms and then you average them or combine them together? That's probably
Yeah.
not the right answer. But what I think is really interesting about the ensemble models that we work on is it's not just a bunch of tiny models running in parallel, it's also hierarchies across scale. And so
Yeah.
one of the biggest problems in audio synthesis, especially these voice agents, is latency. You want to hear something and respond immediately. Well, if you want super low latency, you need to run on device on the edge. If you're running on device on the edge, you have to run a less powerful model. And so they're either slow and kind of smart, but still not that smart, or they're really fast and super, super incompetent. If you
Mhm.
think about starting to break this stuff up, you can run a small edge model that could be super incompetent and then give it context, very rich context that you're extracting from a larger, more capable
Yeah.
model that's somewhere in the cloud. And you can do this multiple different times at different hierarchies. So the small model that itself would be completely incapable of doing this now has all this extra metadata and
Yeah.
information from the bigger models
Totally.
elsewhere.
Yeah, that makes a ton of sense. Like, the model that's basically, if we just think of it from like text to speech, where it's like the model that's taking the text and then generating the voice from it, you know, as opposed to, I don't know if this is the way you'd approach it, but if instead you've broken down the text with the intonation, with the emotional resonance that you're looking for, and you've turned that into a different stream of tokens, which is, maybe closer to phonemes or something like that, where it's no longer, it's not, it's now just solving like the next layer down that can be much more efficient on a faster, lighter model.
Exactly right. Yeah, you do the decoding at the edge where you have to do it really fast, and then you do the conditioning up somewhere else where you can afford a 1 second delay if you really, really need it. And honestly, that's kind of how I feel like I work sometimes, because like I'll start talking, and then as I'm saying the next word, I'm like, wait a minute, what exactly, where was I going with, what's the next word that I'm supposed to say? And so I've got that, much more powerful, it feels like cloud-based model coming in and being like, where was the synthesis model locally going with that? Like,
Yeah, exactly. Yeah.
Maybe that's what happens when like you walk into a room to do something or say something and you've forgotten it by the time you get in there, is that the model in back is just really latent.
I feel like that must be like a lossy connection or something. It's like pinging and it's like, oh yeah, retry, just couldn't get the connection.
Or it's like every time I have to do my two-factor authentication to sign in, I look up and it's an hour later and I've been watching, TikTok reels or something like that. The Edge model has an interrupt that gets interrupted on lower level things that, you know.
See, I thought I had that problem solved because I have the little key fobs on my car keychain, and I'm just like, okay, great, that's not a phone. I'm just gonna plug it in and press go. Well, of course, Google decides to log me out when I'm at a hotel that doesn't have any self parking. It's only valet. So the valet has my little
Oh no.
key fob on my car keys, and of course I have a backup that's in my desk drawer at home, three
Oh
thousand miles
no.
away. So that was that was a rough day. I'm just like, I hope the rest of the team has it because I can't get into GitLab. So, good luck.
That is a single point of failure that had never occurred to me before. The hotel valet.
You think you've got it because you're like, okay, it almost never asks me to re-authenticate. And when it does, I've got my key fob on my keychain. And when I don't, I've got the one in my desk. And somehow, but of course, because you're traveling, so it's like that's a suspicious login. And you're away from home, so you don't have the backup one in your desk. And you're at a hotel, so it's on the key. It's like a perfect coincidence. Like I did not think of those correlations of systemic failure.
There you go.
Well, Carter, that seems like a great place to wrap it up with the loss of your car keys.
Spoiler, I did get it back and I did get back into GitLab. So just
That's
for any
that's
compliance folks out there, we did not lose
we
the
didn't
CTO's access to our
we,
code base.
we, we nobody had to circumvent that particular
Not
2FA.
this time.
Thank you very much for joining us today. This has opened my eyes. I will tell you, I don't know if you can see it, but my gears are turning here. I've been spending this whole hour thinking about how could we use this? What can I do with this? This is like a new tool I didn't even know I had in my, or a new toy I didn't even know I had in my toy box. Now what am I going to do with this thing?
Yeah, for sure.
Well, I hope you sign up, try our models, try our APIs. If you're really good at getting those gears thinking, your kind of cloud-based model comes back and says, "Wait, I've got an idea." Yeah, go sign up, go try it out. We love hearing about what kind of cool stuff people do with our tech. So super great to be chatting with you both. Thank you so much. I really
Yeah.
appreciate it.
Yeah, I'm so glad you're able to come on and chat
Yeah.
with us about this. Very, very cool product. Very cool solution to a hard problem. I love that you're solving it at
Hmm.
scale. I love that you're thinking outside the box of the current sort of like the current hammer that's solving all of the things. So yeah, love it. Well, there you go. I guess we'll say to our listeners, thanks for listening to another episode of the How Many CTOs Does It Take podcast. Thanks for coming, Carter.
Thanks, Carter.
See you next week.
See you next week, Brad.
This episode of How Many CTOs Does It Take podcast was edited by Saffron Hefta-Gaub. Our theme song was AI generated by Brad. Please follow us on all the social media platforms at How Many CTOs Pod. You can find us on YouTube, LinkedIn, Instagram, Facebook, Threads, X, TikTok, and Patreon, or at our website at howmanyctospod.com. And remember to rate, review, and subscribe on the podcast platform of your choice. Thanks for listening.